So in this screencast, we're going to talk about the good and the bad about ozone. This is meant to be a very quick 30,000 foot overview of ozone, the ozone hole, and humans making the world a worse place. Not meant to be any sort of high level discussion. Just sort of a low level, make you an informed consumer, if you will. So ozone, which is in a stable form of oxygen, although it's in very low concentrations here in the Earth. Ozone in the troposphere is the part of the atmosphere that's down where we are. So essentially from ground level or sea level up to about 12 kilometers or 7 miles up or so. The natural source of ozone is electrical storms. And you're probably familiar with the smell of ozone, you just don't know it. It's that sort of sweet smell that you smell during a hard rainstorm. And it comes from sort of the electrical storm, or in heavy rainstorms, that's where you get that ozone. And it's very, very pungent, and it's very toxic at very low concentrations. We also make it ourselves. It is a pollution. It comes from, it comes out of tailpipes. It is a component of smog. So in places like Los Angeles, California, where the weather doesn't exactly move on because of the mountains, students actually skip school because of ozone days. Like we have snow days here in the Midwest, they have ozone days in Los Angeles because the ozone's too high. It's unsafe for kids to go out and play. Now, the ozone that most people are concerned about is not the ozone that we get here in the troposphere from pollution, but from the ozone in the stratosphere. The stratosphere is the next highest group or part of the atmosphere, if you will. And that's a distance from 12 to 50 kilometers. So that's roughly 7 to 30 some odd miles up in the air. And up there, there's ozone, the ozone layer, if you will. The ozone layer that Mother Nature, the ozone is sort of formed and destroyed by Mother Nature through a series of complex reactions which are not important at this point. You just need to understand that there's a certain concentration of ozone that is made and destroyed. And the destruction of the stratospheric ozone is exactly what we want in this case, because that ozone is being destroyed by the ultraviolet radiation that, if it wasn't for the ozone, the ultraviolet radiation goes through and gives us all skin cancer. That's what's happening, is we're getting rid of that ozone so it's not there to sort of react with the incoming ultraviolet radiation, preventing skin cancer and other things bad for plants and such. We'll talk about that in a little bit. So the reason why we're actually getting an ozone hole, there are several causes, but the most notable is the production of what are known as chlorofluorocarbons. Chlorofluorocarbons are a group of compounds, all man-made, and they're great for sort of propellants. So it's used as refrigerants, and air conditioners, propellants for fire extinguishers, hairspray, all sorts of stuff. And it was really great because it's chemically inert. So, if you're in your bathroom and you're putting a half a can of hairspray in your hair, you don't want the gases coming out of your can to be toxic, because, you won't be able to sell very many cans of hairspray if you do that. So you need something that's completely inert, that doesn't bother humans, doesn't bother plants, doesn't bother the cat. And chlorofluorocarbons are great for that. The problem is that it's chemically inert in the troposphere, and so it doesn't react, so it doesn't break down. That's bad, because then what happens is it slowly meanders and stays around forever, and eventually it sort of meanders up to the stratosphere. And when it gets to the stratosphere, well, then it's not inert. It reacts with radiation coming from the sun and other stars in the universe, and it falls apart into these two pieces. Now, this is a way that we use to write what are called radicals. So a neutral chlorine atom, has 7 valence electrons. And that's exactly what this chlorine is. It has 7 valence electrons. It's extremely reactive because of that one unpaired electron. And so we sort of show that by putting a little dot there. Right? So we're sort of like cutting this bond in half. One electron goes back to the carbon, the electron goes back to the chlorine. And we get what's called a chlorine radical, sometimes referred to as a free radical. Free radicals are very, very bad and very, very reactive. And in this case, what it's doing is that free radical chlorine will go and react with the ozone, form this chlorooxy radical, then another oxygen, and then hits another free radical oxygen, which are around from the process of making ozone and such. Going away, reacts, and we get this free radical chlorine back out. So if we sort of add these up, this is sort of our net reaction. Now, as you can see, we have a chlorine sort of here on the reactant side of an initial reaction, and then on the product side of a later reaction. Notice it's not in the net reaction. This is the textbook definition of a catalyst. Catalyst is something that makes the reaction go faster. I mean, that's the net effect usually. Make the reaction go much, much faster because it's sort of a reactant that gets recycled. And this is why these chlorofluorocarbons are so bad, in that it has been calculated that one chlorine radical has the ability that it will, this is a very energetically favorable reaction, and it will chew through 100,000 ozone molecules before it goes off and does some other side reaction, sort of stopping it. So for every one chlorine radical that's formed in this first reaction, 100,000 ozone molecules go bye-bye. So it's not too much of a stretch of the imagination to understand that the concentration of ozone is going to drop pretty darn fast with just a small amount of chlorofluorocarbons. And what's very interesting is that this is one of those cases where countries around the world, as soon as they sort of figure this out, that this is a bad thing. And within 10 years of scientists, you know, those people who often get vilified in today's political arena, scientists were listened to, and all of the major industrialized countries, and even this, you know, a lot of the second-tier countries, almost everybody except for a couple of, you know, wackos out there, all agreed that this stuff was bad, and they banned it. So it is now illegal to make this stuff and put it into propellants and fire extinguishers. It took less than 10 years to convince the entire world that this is a bad thing and we should stop it. That never, ever happens. Ever. We don't even agree. We don't agree about a whole bunch of stuff. The fact that you get the whole planet in agreement about, oh yeah, this chemical is bad, we should ban it, in less than 10 years? Really? How is that possible? How is that possible, considering our history as a human society? I don't know. Couple last notes about ozone destruction. We know that the ozone layer is thinner at the equator. It's always been thinner at the equator, which is part of the reason why we get a lot more radiation, like ultraviolet radiation, in the parts of the world that are closer to the equator. And I don't know if you know this, but people who live close to the equator generally have darker skin. And the reason they have darker skin is because their ancestors have been hanging on the equator, where they get a lot more ultraviolet radiation. So they get darker skin, less skin cancer, if you will. And those people up there in Scandinavia who have very light skin, they have, the ozone is up there, and they don't get nearly as much ultraviolet radiation, and so their skin pigment is lighter. That's what happens. So there's less atmosphere down there. Ultraviolet rays also damage green plants, the algae in the ocean. It has a very negative effect. So the ozone destruction is not just a bad thing for humans, given it's all skin cancer, but it also damages green plants. That's bad. A decrease in the concentration of ozone by only 4% can result in a 12 to 40% increase in the amount of ultraviolet radiation, depending on where you are on the planet. So small changes in ozone concentration can have a very large change in the amount of ultraviolet radiation that hits the Earth. And chlorofluorocarbons are not the only culprits that kill ozone. Free radical hydroxide and dinitrogen monoxide, which is known as laughing gas, also kill ozone, and those are also pollutants. So it's not just the chlorofluorocarbons, there are other things, but chlorofluorocarbons are the really nasty ones because of that catalytic decomposition.